Greetings. This is the Verbal Antidote channel. Back again with a very, very interesting video. All right. Wait a minute. Cern have opened a portal for interstellar travel of the unidentified aerial phenomenon, an interstellar lower type aircraft, drone-like aircraft, small dish-shaped aircrafts coming in and out a portal connected to the ocean. Matter of fact, could the drones be coming from the most infamous portal in America, offshore of the southeastern shore, the West Indies, as we all know, Bermuda, the Bermuda Triangle? Has Cern waking up, open up a portal next to the Bermuda Triangle? Watch. What do you think? Nobody thinks. Likes the black Bruce Wayne, journalist, debonair. All right, let it rip, y'all. Fair use.
We are massive, we are solid, because our particles are interacting with that cosmic treacle or whatever.
Watch.
Cern has been at the forefront of many of our astronomical discoveries. Their studies have spanned from the possibility of the existence of other dimensions to the existence of life in other universes. They do a lot of their research with a machine called the Large Hadron Collider, which is around 17 miles long and buried beneath the surface, traversing the border between France and Switzerland. But most recently, Cern made some progress with the Large Hadron Collider, also called the LHC, and it just may change everything we know about the world. What's happening with LHC? The Large Hadron Collider, also called the LHC, is one of the most significant achievements of modern science. It is the largest and most intricate machine ever built by humans, and some consider it the world's largest freezer. This massive machine is 17 miles long and buried beneath, traversing the border between France and Switzerland. The LHC is run by Cern, a famous science organization where researchers explore the secrets of the universe with the sole aim of making tiny particles, like protons, move almost as fast as light and then collide them into each other. Once these collisions happen, they bring about the conditions which existed immediately after the Big Bang, and in turn allow scientists to investigate the early moments of the universe and the smallest building pieces of everything in our environment. And now, something significant has happened at Cern that changes everything. One of the LHC's most important discoveries is the Higgs boson, otherwise called the God particle. Following the discovery of this particle, it explains the existence of mass for everything in the universe, which is significant in showcasing how the universe operates. However, the LHC has pioneered various unexpected results that scientists are trying to comprehend. For example, the LHC's detectors have detected more particle collisions at specific energy levels than scientists anticipated. These unexpected findings contradict the Standard Model's assumptions, which scientists use to understand how tiny particles behave. This suggests that there may be new discoveries waiting to be made. Scientists have also studied beauty quarks, a sort of particle, and discovered that they do not behave in the way that the Standard Model predicted. This could indicate that there is a completely new type of physics that we do not yet understand. Another enigma is neutrinos. which are small particles that rarely interact with anything. Scientists once believed that neutrinos are likely to travel faster than light, which would in turn contradict Einstein's theory of relativity. In the pursuit of answers, scientists also theorize that there is a possibility that other dimensions may exist, and if they are correct, the particles would behave differently there. However, this turned out to be a blunder, and it increased people's interest in the concept of extra dimensions. These are dimensions that go beyond the three we normally experience: length, breadth, and height. Several scientists strongly believe our cosmos may contain extra dimensions, but they are too tiny and hidden for us to observe. The LHC's experiments may reveal these dimensions for a brief period of time. If extra dimensions were to exist, then they may contain new forms of particles, known as Kaluza-Klein modes. If the LHC discovers these particles, it will serve as proof of extra dimensions and fundamentally alter our understanding of the cosmos. Furthermore, scientists are continuously striving to unlock the riddle of gravity. Gravity is the force that brings things together, yet it is far weaker than other forces in the cosmos, such as magnetism. Several researchers strongly believe gravity may expand into extra dimensions, and the LHC could be beneficial in testing this theory. Following the hunt for extra dimensions, it analyzes particle behavior at the Large Hadron Collider LHC, which includes how they decay, move, and interact under severe conditions. The LHC, the world's largest particle collider, assists scientists in recreating conditions similar to those that existed immediately following the Big Bang. Cern can monitor how particles behave by colliding them together at extremely high speeds, potentially revealing hidden features of the universe, such as other dimensions. One possibility is that particles may interact with these extra dimensions, resulting in less energy or momentum in collisions. When this occurs, it results in missing energy or missing momentum, which scientists are attentively researching. So far, scientists have not discovered concrete evidence of extra dimensions, but the data acquired at Cern raises intriguing possibilities. For example, the absence of energy or momentum in particular collisions could provide a clue. These anomalies indicate that there may be more to the universe than we currently understand. Scientists hope to discover additional hints by monitoring the breakdown of particles. If particles interact with other dimensions, their decay patterns may differ from our expectations. Researchers meticulously analyze these patterns in search of indications that corroborate the existence of these hidden dimensions. On average, some of these particles are more heavy than expected, leading scientists to question whether they are interacting with dimensions or unseen forces. These discoveries are a clear indication that we still have a long way to go in learning about how the universe operates. Cern is more than just an experimental facility. It is also a place of scientific discovery. Scientists are revealing hidden facts about existence by recreating the conditions of the early universe. Their work improves our understanding of the universe and pushes the boundaries of human knowledge. The discoveries at the LHC might completely change how we see the universe. The prospects for discovering new particles, exploring unknown dimensions, and comprehending gravity are limitless. Every new discovery creates questions and motivates scientists to seek answers, allowing us to learn more about the universe. Finally, Cern's work focuses on answering big questions, such as how the cosmos began and what it is made of. This continual exploration is about more than just discovering answers. It is also about pushing the limits of our understanding. Another area of Cern research is a bizarre phenomena known as quantum entanglement. In quantum physics, particles can become entangled, which means that the state of one particle affects the state of another, regardless of how far away they are. This calls into question our fundamental concepts of space, time, and cause and effect. Cern scientists are investigating quantum entanglement to determine if it can reveal information about other dimensions. Scientists want to learn more about how particles are related by experimenting with quantum entanglement, and whether this peculiar behavior could lead to a link between our universe and another realm. In addition to quantum entanglement, Cern researchers are investigating miniature black holes. These microscopic black holes are far smaller than the ones we know about, which are situated in the centers of galaxies. According to some ideas, such as string theory, extra dimensions may result in the formation of miniature black holes at the energy levels produced by the LHC. Although these black holes would be extremely small and vanish nearly rapidly due to a process known as Hawking radiation, their presence could give compelling proof for the existence of other dimensions. Although micro black holes are hard to find, they might leave unique signals in detectors if they are produced at Cern. By closely examining these signals, researchers expect to gain a better understanding of the interactions between particles and these small black holes, which could lead to the discovery of hints regarding the structure of extra dimensions. Although the safety of producing these black holes is questioned, scientists are certain that Hawking radiation would stop them from expanding out of control. Rather, they think that these micro black holes would stay little and not be dangerous. Micro black hole research could also help scientists understand gravity, one of nature's fundamental forces. The development and death of these black holes, as well as the particles they emit, may offer vital information about the nature of space and time. This research may even help scientists get fresh insights into the universe's structure and operation. Even while no direct evidence of extra dimensions has been discovered, Cern's investigations continue to provide intriguing indications about what lies beyond our current comprehension. The search for a portal to another dimension continues, and with each experiment, scientists get closer to potentially uncovering hidden dimensions or understanding how they might exist. The Higgs boson, a particle that gives other particles mass, is one of Cern's most intriguing findings. The Higgs boson explains why particles have mass, which is important for understanding how the universe operates. However, scientists aren't only interested in the Higgs boson because it gives particles mass. They're also looking into how it would behave differently if the cosmos had more dimensions than the three we normally experience. At Cern, scientists carefully measure the mass of the Higgs boson and compare it to what theories predict. This allows them to test many concepts, including the possibility of hidden dimensions. If more dimensions exist, they may affect the Higgs boson in subtle ways, such as modifying its mass or how it decays. The Higgs boson's role in imparting mass to other particles makes it critical to our knowledge of particle physics. Scientists seek to discover differences that may indicate the presence of hidden dimensions by investigating their features more closely. These minor discrepancies could provide vital clues about the underlying structure of the cosmos, allowing scientists to answer some of the most pressing issues in physics. While Cern has yet to reveal convincing confirmation of extra dimensions, its study is yielding fascinating new insights into the universe's deepest secrets. Scientists are determined to continue exploring, as each new discovery may bring us one step closer to unlocking the mysteries of the cosmos. Finally, whether or not we find a direct bridge to another dimension, Cern's research advances our understanding of the universe. It encourages us
Thanks
to
for
think
watching.
beyond the boundaries of our current
This is the
knowledge,
Verbal Antidote
bringing
channel.
out fresh ideas for what might exist beyond
Like,
the conventional three
share, and
dimensions of
subscribe.
space. Scientists are also looking at gravity in a different light, and what they are discovering so far is mind-bending. A new look at gravity. Another concept that CERN scientists are studying is something called gravity's rainbow. According to the theory known as gravity's rainbow, gravity may act differently depending on the energy involved, particularly if there are additional dimensions. The theory attempts to integrate Einstein's general theory of relativity, which describes how gravity functions on large scales, with quantum mechanics, which describes the behavior of extremely small particles. According to certain models, gravity may not behave normally when particles interact with additional dimensions. Instead, it could behave in a way that depends on the energy of the particles involved, creating a kind of rainbow effect of gravitational behavior. Scientists hope that studying this effect could give them more clues about whether extra dimensions are real. If scientists find that gravity acts differently when particles are very close to these hidden dimensions, it could suggest that other dimensions exist. While doing this, they are also searching for dimensions, and it seems like they have gotten closer to a new answer, a partner for every particle. Supersymmetry is one concept that is strongly related to extra dimensions. According to the theory of supersymmetry, every known particle has a companion counterpart with distinct characteristics. For instance, a particle known as the selectron would be the electron's spouse. A number of particle physics problems, such as why some particles have the mass they do, or why gravity is so much weaker than the other forces of nature, may be resolved with the aid of supersymmetry. Supersymmetry also connects to the study of extra dimensions, because it suggests that these hidden dimensions could help stabilize the universe. For example, extra dimensions could keep energy levels, like the weakened Planck scales, from becoming unstable. Scientists at Cern are working hard to locate evidence for supersymmetry and determine whether it is linked to extra dimensions. However, they have yet to find convincing proof, raising worries about the models and theories that rely on supersymmetry. If these theories are proven to be correct, we may be able to change our view on energy. A closer look at energy and momentum. Another exciting area of study at Cern involves the idea that energy and momentum conservation might not always hold true, especially when particles interact with hidden dimensions. Normally, when particles collide, the total energy and momentum stay the same, but some theories suggest that energy and momentum might appear to change during collisions if the particles move into extra dimensions for a brief moment. This concept contradicts everything we currently know about the laws of physics. It might lead to new ways of thinking about the universe if it is true. In order to find additional proof for the presence of extra dimensions, scientists are examining this to see if they can find any indications of energy and momentum violations. It's an intriguing field of study that could reveal mysteries about the true nature of the cosmos. The basics of string theory. String theory is an effort to explain the universe's underlying forces and components. It implies that the fundamental building elements of the universe are not point-like particles, as previously assumed, but small vibrating strings. These threads vibrate at different frequencies, resulting in particles with distinct characteristics. According to string theory, these strings could explain how all of the fundamental forces, gravity, electromagnetism, and strong and weak nuclear forces, work together in a single framework. The theory predicts the existence of extra dimensions. While we are familiar with 3 spatial dimensions and 1 temporal dimension, string theory proposes that there may be extra dimensions that are curled up and extremely small, rendering them invisible to us. These extra dimensions could provide the key to understanding phenomena such as black holes, the Big Bang, and possibly gravity itself. And now, some new things are unfolding at Cern that will change our view of the cosmos, unlocking cosmic secrets at Cern. Scientists expect that by analyzing the data from the high-energy collisions from the LHC, they will discover evidence of extra dimensions or new particles predicted by string theory. For example, certain LHC collisions have yielded unexpected results in which energy appears to disappear. This could imply that particles go briefly into hidden dimensions before returning to our visible space. Such occurrences contradict accepted rules of physics, such as energy and momentum conservation, and open the door to discovering new particles or forces beyond the standard model. String theory predicts the existence of string excitations, particles resulting from the vibrations of these fundamental strings. If discovered, these particles could support the concept of extra dimensions and provide a better understanding of how the universe is structured. The many worlds interpretation. Another groundbreaking concept being investigated at Cern is the many worlds interpretation of quantum mechanics. This theory claims that whenever a quantum event occurs, the universe divides into several branches, each representing a different conclusion of the event. Essentially, there could be multiple parallel universes, each with small differences from our own. The MWI helps to explain the unusual behavior of particles